Hey everyone, welcome to 5.2. Here are some examples using the log rule. Alright, so the first one is the integral of 3x squared plus 1 over x cubed plus x dx. Now the ones we're doing here today, we're going to be using u substitution. So let's just say that u equals x cubed plus x. So that means u prime is going to equal 3x squared plus 1 dx. Oh, great! That works out really well. Yeah, so that means we can say this is really the same as the integral of 1 over u du, right? Great. So that means we're going to say that is the natural log of the absolute value of u plus c, and then let's just plug u back in, so we can say that's the natural log, the absolute value of x cubed plus x plus c. There we go. So we can use u substitution with logs as well. Alright, so let's look at this one. The integral of secant squared over tangent x dx. Alright, so let's just say that u equals tangent x. And if you remember, the derivative of tangent is secant squared x dx. Alright, so that means we can really say this is going to be the same as the integral of 1 over u du. Oh, great. So that means it's going to be the natural log absolute value of u plus c, which then we can say is the natural log of the absolute value of tan x plus c. So there we go. So we can use this. All right, so let's do the same thing. Let's keep rolling here. Yeah, seems like a good idea. The integral of x plus 1 over x squared plus 2x. So let's say u equals x squared plus 2. That means du is going to equal 2x plus 2 dx. You say, oh no, I've got a problem. I've got 2x plus 2 as my derivative of u, but I don't have that 2x plus 2 here. I have x plus 1. So really what I have to do is if I divide this by 2, divide this by 2, we should be okay, right? So I can say this is the same as 1/2 integral of 1 over u du. Okay, so we can say that's the same as 1/2 natural log of u plus c, which then we're going to say is 1/2 natural log absolute value of x squared plus 2x plus c. So even if it doesn't line up perfectly, if the du doesn't take care of all the rest of the stuff, you can kind of manipulate it as long as it's only a constant, not a variable. So we can't say, oh, it's just 1 over x out in front, because now we're kind of changing the integral and what we're trying to do here. All right. So kind of the same thing for this last one here. We're going to say, let's say u equals 3x plus 2, and that means du is going to equal 3 dx. Okay, we'll divide by 3, and I can say this is going to be the same as 1/3, let's see if I can write it here, 1/3 integral of 1 over u du. Okay, so I can say that's going to be the same as 1/3 natural log absolute value of u plus c, which is going to be 1/3 natural log absolute value of 3x plus 2 plus c. So we can kind of manipulate these u's to get to what we want to do. So that way, if we have extra stuff or things that don't quite work out, we'll say, well, we want to get rid of this. We need this. I want this 2 here. I need this 3 here, something like that. We can manipulate this using u substitution. All right, there you go.